We talk a lot about how powerful AI is, right? But what about how fragile it can be? Well, we're going to dive into some incredible research that exposes a massive vulnerability in some of our biggest and most important AI models. And get this, it's an attack that's cheap, it's practical, and it's been hiding in plain sight this whole time. So let's just start with the big, dramatic question. How would you even go about sabotaging a multi-billion-dollar AI? One that's been trained on, a huge chunk of the entire internet. You're probably thinking it takes a state-sponsored supercomputer, maybe a whole team of elite hackers, but it turns out the price of admission is a lot lower. Yep, $60. For less than you'd spend on a new video game, researchers figured out you could start a serious attack to poison the training data that these massive AIs learn from. So how is that even possible? Well, it all boils down to a fundamental weakness in the way we build these giant datasets in the first place.
Okay, so to understand how to pull off this $60 heist, you first have to get your head around where AI models get their knowledge. They learn from these things called web-scale datasets, which are pretty much what they sound like. Enormous lists of content scraped from every corner of the internet. And that, right there, is where the trouble starts.
You see, these datasets aren't like some nice, neat, verified encyclopedia. For a bunch of reasons, mostly legal and storage, they don't actually hold the images or the text themselves. Instead, they're just a gigantic list of URLs. Basically, links. The AI developer then has to go and download all the stuff from those links. And this creates a really dangerous time gap between when the list was made and when it actually gets used. So this brings us straight to the first attack. I want you to imagine a dataset is like a giant address book for the internet. Now, what happens if someone moves out of their house, but their address is never taken out of that book? Well, someone else can move in and start getting all their mail, right? That is exactly what's happening online with something called expired domain names. The researchers have a brilliant name for this: split view poisoning. It's perfect because it means the person who made the datasets and the person who uses it have a split view of reality. The creator saw a harmless picture of a cat at some URL, but months, maybe years later, the domain for that URL expires. An attacker can just buy it up. And now anyone using that old address book to download the cat picture gets, well, whatever poison data the attacker wants them to have. The most important thing here is just how ridiculously simple this is. Okay, step 1. A dataset creator finds a cool picture and adds the URL to their list. Step 2. Time passes, and the original website owner just forgets to renew their domain. It happens all the time. Step 3, an attacker who's been watching these datasets snatches up that expired domain for next to nothing. And bam, step 4, they're in control. They can now serve up malicious data to any AI developer using that original, trusted list.
All right, so that's one way in. But what if you can't just buy up a domain and hold on to it? That brings us to the second type of attack. And this one is all about perfect timing. Think of it like trying to slip a fake photo into a time capsule, just seconds before they seal it up. Even if someone notices your fake a minute later and takes it out, it doesn't matter. It's already been immortalized in the capsule. This is called front-running poisoning. It's aimed at datasets that are built from snapshots of live, constantly changing websites, and Wikipedia is the perfect example. Now, you can't just go vandalize a Wikipedia page because it'll probably be fixed in minutes. But if you can predict the exact moment the official snapshot is being taken, you can inject your malicious data, have it captured in the snapshot, and it's now a permanent part of that dataset forever, even if the live article was fixed 60 seconds later. Now, you're probably thinking, how could you possibly predict that timing? Well, take a look at this. This shows the attack isn't just a theory. This sawtooth pattern here shows that the process Wikipedia uses to take snapshots is shockingly predictable. Each of those straight lines is a computer just crawling through articles one by one, in a simple order. By looking at old snapshots, an attacker can figure out the exact minute a specific article is going to be saved. It's basically a public roadmap for sabotage. So let's just quickly put these two attacks side by side. You've got split view poisoning, which is the long game, gaining sustained control of a domain. Then you've got front-running poisoning, which is a lightning-fast surgical strike but relies on a predictable schedule. One is about patience, the other is about timing. Both are incredibly effective. Okay, so we've covered the how. The theory is clever, for sure. But this is where the story gets genuinely alarming. The researchers didn't just dream this up. They went out and measured just how vulnerable some of our most important datasets actually are. Just look at these numbers. For only $1,000, an attacker could buy up enough domains to control a pretty significant chunk of these datasets.
Look at face scrub, over 0.5%. Now, I know 0.5% might not sound like a lot, but other research has shown that you only need to poison as little as 0.01% of the data to install a backdoor in an entire model. And that tiny 0.01% number, that critical threshold, this is what brings us right back to that $60 price tag. For absolutely gigantic foundational datasets like Lion and Koyo, the researchers found they could easily buy enough expired domains to hit that magic number. It's just terrifyingly efficient. And to prove this wasn't just hypothetical, the researchers bought some of these vulnerable domains themselves. Don't worry, they didn't do anything malicious, they just served an error page. Over 12 months, they saw over 800 different people and organizations downloading data from their trapped domains. This means people are actively using these poison datasets right now. So what about that Wikipedia front-running attack? Well, their conservative estimate found that an attacker could successfully poison around 6.5% of the articles in a snapshot. That is an absolutely enormous attack surface, way more than you'd ever need to successfully corrupt a model. Okay, so this all sounds pretty bleak, I know. It's a huge security hole in the foundation of modern AI. But here's the really good news. These problems are completely fixable, and the researchers didn't just point fingers, they came up with clear, effective solutions. And the solutions are actually pretty elegant. To stop the expired domain attack, all you need is an integrity check. It's like a tamper-proof seal. The dataset creators just need to publish a unique digital fingerprint. It's called a hash for every single file. When you download the file, you check its fingerprint. If they don't match, you know something's wrong. And for the Wikipedia problem, the fix is even simpler. Just shuffle the deck. Randomize the order of the snapshot, and the attacker's roadmap becomes useless. And here's the best part of the whole story. This wasn't just an academic exercise. The researchers did the right thing and privately told the owners of these datasets about the flaws. And because they did, 6 of these major datasets, including the massive Lion collection that powers so many models, have already implemented these integrity checks. This research has already made the entire AI world safer. That's a huge win. So all this leaves us with one last big thought. These attacks work because we've all been operating on a flawed assumption that a link today points to the same thing it did yesterday. This research proves that's a dangerously naive way to think. And as we build more and more of our digital world on top of AI, we really have to ask ourselves, what happens when we can't trust the very data it's built on?